structural engineering, and then he has pursued his further higher studies, and he has done his PhD from Kalinga University, and he is one of the resource person in many of the national and international conference. Also, he is regularly publishing his work in various other journals from international repute, and he is interested in the analytical techniques which are involved in the civil engineering. Especially, he looks after in CIF team the XRD machine, and also he is involved in the various activities of CIF, where he is a key member of this CIF team. So, with this brief introduction, I hand over the mic to Dr. N.K. Dhapekar. He will be telling you about the use of HPLC in the engineering field. So, over to you, Dr. Dhapekar.
Thank you. Thank you very much, Dr. Kola sir. So, good afternoon to all the participants. My voice is audible?
Yes, sir.
Okay. So,
Yes,
very
sir.
good afternoon. Okay, good. Very good afternoon to all of you. So, today the topic which I am going to deliver is high performance liquid chromatography HPLC and its application in civil engineering. In civil engineering, application of HPLC, high performance liquid chromatography. High performance means resolution, and resolution means distinguish. With the help of this equipment, we can distinguish the components, we can separate the components. See here, suppose let us take an example of chemical admixture, and in that few compounds are there. My aim is to study only one compound which is responsible to alter the properties of concrete. Then in that case, I can separate that particular compound, I can identify that compound, and I can quantify that compound. That is only possible with the help of HPLC. High performance sometimes may be called as high pressure also, because when we inject sample in stationary tube, we use pump. So sometimes it may be called as high pressure liquid chromatography also. Basically, if I talk about the civil engineering, chemical admixtures, thousands of chemical admixtures are there. Nowadays, in every construction activity, chemical admixtures are used. High performance chemical admixtures, retarders, and in every chemical there are key compounds. So these key compounds, if we have to identify and quantify, then obviously this instrument will work very precisely. So let us start that how this HPLC works and what are its components. HPLC is very efficient, and we can say that this instrument is very efficient in providing us the separation of compounds. Earlier days, this HPLC was used, but nowadays this Martin and Singe, they have worked and modified this HPLC. And if you will look research papers, if you will go through the research papers, you will see now the researchers are working on reverse HPLC. Now, what is the difference between HPLC and reverse HPLC. I shall explain you. This instrument HPLC, as you might have listened to the lectures related to HPLC since morning, you might be knowing that this instrument basically work upon the concept of polarity. Polarity is nothing but the tendency of molecule to like or dislike water molecule. If a compound is getting attracted and developing bond, we call it as hydrophilic. If a compound dislikes water molecule and bonding doesn't take place, it's hydrophobic. We may call it as non-polar compounds. So the principle is based upon the polarity. See here, this is the stationary phase. In a CIF, we have HPLC with C18 compound packed within it. But earlier, this solid adsorbent material packed in a stationary phase, mostly widely, silica is used. It acts as a hydrophilic, and when we talk about the reverse HPLC, then silica with C18, if we introduced in a packed manner in this tube, then it acts as a hydrophobic. So there are three components stationary phase, one is the sample and one is the mobile phase. Mobile phase consists of 90% of the water and 10% of the organic solvent, which is pumped with pressure. When the sample is added with and it
Excuse me,
passes
sir.
through this tube.
Are you sharing slide?
Okay, okay, okay. Okay, your good name, please.
Sir, Chandni Afsana. I
Okay,
can't
okay, okay.
see
Okay,
the.
rest other participants actually they are listening to me, but they have not asked me.
I can't understand. That's why I ask you.
Hmm, 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 hmm. Okay, now is it visible? It's visible
No,
now,
sir. No, no, sir.
but I have shared my screen.
Issue from her side.
Other participants, the screen is visible to all of you.
Yes, sir.
My screen, if it is not visible, please get out of the classroom and then re-enter again. You may get. So should I proceed now?
Yes,
So,
sir.
okay,
Now it is visible, sir. Thank
okay,
you.
good. So, I am going here to discuss the application of HPLC in civil engineering. So, chemistry is not my concern, but how the chemical admixtures can be studied and the quantification of the compound which plays a major role in altering the properties of concrete, that is possible in HPLC, that I want to show here. So this is the tube, stationary phase, silica, mostly it is used in a packed manner and it acts as a hydrophilic. And when carbon C18 is used along with silica, reverse HPLC, we can work, and nowadays mostly researchers are working on reverse HPLC. So if the mobile phase, which comprises of 10% organic solvent and 90% water, is pumped along with the sample may be blood sample, biochemistry, or in chemistry toxins. In civil engineering, samples may be admixtures, superplasticizers, cement added with water. If these samples along with this mobile phase are pumped in this tube, then this stationary phase is hydrophilic. So the molecules which will not be able to create the bonds will come out of this tube, which will be detected by the detector. And when it will move further from the detector to the system, we can get graphs. So, see here. These graphs are known as chromatograms, and retention time is plotted as abscissa and concentration on y-axis. The graphs which we are getting here, if we calculate the area, we get the quantity of that compound. Now, let us think about the concentration gradient. After some time, in this mobile phase, water is reduced from 90% to 10%, and the organic solvent is increased from 10% to 90%. Polarity changes. Now that stationary phase starts behaving like hydrophobic, and after some time we get compounds out of that stationary phase, those who were adhered within the tube. So this is the whole principle, the concept of getting the chromatographs for particular compounds through HPLC. Now, as we are conducting this session in online mode, I shall try to show you one video. Please watch this.
Tips and tricks can completely transform the way you prepare for IELTS.
Here are one quick biochemistry basics here. Let's talk about HPLC. HPLC is also known as high performance liquid chromatography or high pressure liquid chromatography. HPLC is usually a modified column chromatography. In column chromatography, a column is packed with an absorbent material like silica, and the mobile phase is passed down the column because of gravity. But in HPLC, a high pressure pump is attached with the column. The high pressure pump can generate a high pressure up to 40 megapascals. The column is filled with an adsorbent material which has a very small particle size. The small particle size gives a very large surface area for the sample molecules to interact. As a result, the efficiency of separation increases, giving high resolution. Let's see the components of HPLC. The column is made up of stainless steel which can withstand a very high pressure up to 50 megapascals. The length of the column can vary from 5 to 25 centimeters and have an internal diameter of 4.5 millimeter. The flow rate of mobile phase through the column is usually 1 to 3 ml per minute. The stationary phase. As discussed earlier, the stationary phase is made up of an adsorbent material that has a very small particle size. The particle size is kept uniform to obtain a better performance. Usually chemically modified silica, divinylbenzene, etc. are commonly used as a stationary phase. The mobile phase. The mixture of different solvents can be used as a mobile phase. The solvent used depends on the type of sample molecules which are to be separated. The mobile phase solvent can be polar or non-polar. The mobile phase is usually kept in the solvent reservoir. The solvent reservoir is attached with a pump which pumps the mobile phase in the column with a high pressure. Just before HPLC column there is an injector which allows introduction of the sample in the column. The detector. In order to detect the eluate that is sample coming out of the column, the HPLC column is attached with a detector. Different types of detectors such as UV detector, IR detector, fluorescence detector, refractive index detector, mass spectrometer, electrochemical detectors, etc. can be used. The detectors are connected with a computer which collects the information. Now let's see the working of HPLC. As the sample molecules get separated, they are detected by the detector and a peak is obtained on the computer. This peak is plotted with respect to the retention time. To identify the components, we need to have standards. Let's understand this with an example. Let's say we run glucose as our sample and the peak of glucose is obtained at 5 minutes. Next, we run sucrose as our sample and the peak of sucrose is obtained at 8 minutes. Now we analyze the unknown sample for the detection of sugars present in it. Many peaks are obtained in the chromatogram. The peak obtained at 5 minutes indicates the presence of glucose. However, there is no peak at 8 minutes which indicates that sucrose was absent in our sample. The remaining two peaks are still unknown as we don't have any standards to compare their retention time. This is how the detection of sample is done in HPLC, and for the detection we must have the standards. Using HPLC, it is also possible to find the concentration of sample, but before doing so, we need to have standard code. Let's say we take different concentration of glucose and run through HPLC. The peaks of glucose are obtained at 5 minutes, and with an increase in the concentration of glucose, the area under the curve increases. Once the standard information about the area under the curve and the concentration of glucose is obtained, just by measuring the area of glucose peak in the unknown sample, the concentration of the glucose can be estimated. Now let's see different types of HPLC. Normal phase HPLC. In this type of HPLC, the stationary phase is polar while the mobile phase is non-polar. Usually, silica is preferred as a stationary phase as silica has SiOH group which gives its polar nature. During normal phase HPLC, polar molecules are retained on the stationary phase while the non-polar molecules move fast down the column with the mobile phase. Reverse phase HPLC. In this method, the stationary phase is non-polar while the mobile phase is polar. The non-polar molecules are retained on the stationary phase while the polar molecules move fast down the column. Size exclusion HPLC. This method is based on size exclusion chromatography or gel permeation chromatography. In this method, the stationary phase particles are porous. As a result, small molecules gets inside the pores and takes a long time to move, while the large molecules easily pass down the column. Hence, separation occurs based on the molecular size. Ion exchange HPLC. In this method, the stationary phase has an ionic charge. If the molecules of interest has a positive charge, then a stationary phase is kept negative. And if the molecule of interest has a negative charge, then the stationary phase is kept positive. Hence, separation occurs based on the molecular charge.
So the important part is which molecule is your area of interest. How you will decide that you have to go for reverse HPLC and HPLC, that depends upon your molecule of interest. The best example here I have shown this video for civil engineering participants that retarders basically contains these sugar based molecules. So the molecule of interest in retarders used in chemical industries are sugar based molecules. So, if the charge of the sugar based molecules is positive, then our stationary phase, if we are using negative, then we can get good results. So, in chemical admixtures in chemical industries used in civil engineering, this HPLC is very much beneficial. How does the HPLC works? As I have shown here, that this is your mobile phase, this is the sample which we inject, and this combination then passes through this stationary phase, and we get one collector is here, then detector detects the signal, and we get chromatograms. So the next application of this HPLC in civil engineering industries is cement paste. In cement paste, there are many various types of cements, M43, M53, then white cement, and various hundreds of types of cements are there. And the molecule of interest in cement is generally calcium silicate or calcium silicate hydrates. So these compounds can be quantified in a very easy way through HPLC. Before starting this session, I have shared few research papers. Please, I request all the participants to check their chat box. I have shared here two research papers. One is related to the detection of the retarder sugar, and one is related to the hexavalent chromium in cement using HPLC. So I have shared this link. You can go through those research papers and see how HPLC is helpful in detecting the compounds of interest in cement and in chemical admixtures and superplasticizers. Now, as we are in online mode, you might be thinking that how actually the equipment instrument is, how exactly the stationary phase is. In CIF, we have C18 packed in as a stationary phase. So please watch this animated video. In this, you will get whole idea of the instrument, HPLC.
Te ves muy bien.
High-performance liquid chromatography is a technique in analytical chemistry used to separate, identify, and quantify each component in a mixture. As well as other forms of chromatography, in HPLC there is a mobile phase, which forced by a pump to pass through the system. And there is a stationary phase called a column, which located in an oven where the temperature can be controlled. The sample can be automatically injected into an HPLC system by the use of HPLC autosampler, or can be manually introduced into the injector using a syringe. There is also a detector attached to the HPLC system, which measures the analytes after its separation in the column. The pump forces the mobile phase through the column, and then the detector, under high pressures. In the HPLC system, a vacuum pump and a degasser are connected to the pump and used to remove dissolved gases from the solvents. The pump drives each solvent to the mixing chamber, where mixing takes place under higher pressures. HPLC analysis commonly uses isocratic or gradient elution. In isocratic mode, the mobile phase composition remains constant throughout the procedure. Whereas in gradient mode, the mobile phase composition is changed during the separation process. Sample introduction can be accomplished in various ways. The simplest method is to use an injection valve. In the load position, the high-pressure eluting solvent flows to the column directly. The loop is loaded at the atmospheric pressure from a syringe via the needle port. Excess sample exits the loop via vent port. After loading the sample, the valve is switched to the inject position. The flow delivered by the pump flows through the loop, forcing the sample ahead of it, flowing to the column. Then, the valve returns to the load position, and the mobile phase moves the sample through the column. The separation is based on differential partitioning of the sample components between the mobile and stationary phases. The component which has more affinity to the mobile phase, consequently less affinity to the stationary phase, travels faster and eluted out first. And the component which has more affinity to the stationary phase, consequently more interaction, travels slower and eluted later. This separation can be carried out according to which type of HPLC used. There are two main types of HPLC, reverse phase and normal phase. Reversed phase has a non-polar stationary phase and moderately polar mobile phase. One common stationary phase is a silica which has been modified by attaching a straight-chain alkyl group to its surface, such as the octadecyl group, C18, or the octyl group, C8. In this case, the more hydrophobic the analytes are, the more retained they will be on the stationary phase. The more polar they are, the more they will prefer the mobile phase. In normal phase chromatography, the stationary phase is polar, and the mobile phase is nonpolar. This method separates analytes based on their affinity for a polar stationary surface, such as silica. In this case, the more polar the analytes are, the more retained they will be on the stationary phase. The more hydrophobic they are, the more they will prefer the mobile phase. As compounds elute from the column, they interact with the detector. Different types of detectors can be used, such as the UV vis detector, which showing an absorption spectrum in the ultraviolet or visible region. For UV detection, a deuterium discharge lamp as a light source is used. And for components detection in visible region, a tungsten lamp is used. In UV vis detector we can also find entrance slit, lens, prism or diffraction grating, exit slit, flow cell, and detector for absorption measurements. Light from the lamp is shown onto the prism and dispersed according to wavelength. When the measurement is performed with a specific wavelength, the angle of the prism is adjusted so that the light of this wave can shine on the flow cell. As the compounds elute from the column, they enter the flow cell, where the bonding and non-bonding electrons of these compounds can absorb energy in the form of ultraviolet or visible light. The manner in which the final data is displayed is based on the computer and software. The number of peaks present can indicate how many components are in the mixture. Usually, the x-axis of the HPLC chromatogram shows the amount of time taken for the analytes to pass through the column and reach the detector. Typically, the y-axis, or the area of the peak, is a reflection of the amount of a specific analyte that's present.
So with the help of this video, the flow chart how HPLC works, at least you would have come to know. Now, benefits of HPLC. The benefits of HPLC is it provides data in a very nice manner, reporting is very nice, and it is a very powerful instrument, adaptable and affordable. Few safety precautionary measures to be taken while handling HPLC. That in HPLC, apart from these compounds, toxins can also be separated and can be quantified. In civil engineering, I am trying to explain the areas wherein we can use HPLC, concrete technology, cement, pest. Apart from this, detection of toxins in sewage, HPLC can detect in a very nice manner. You can get lot of research papers on this topic. And those who are from civil engineering background, they will know the importance of detection of toxins in sewage. Then detections of toxins in water to study the quality of water. That is also done with the help of HPLC. But while handling these toxic solvents, user should be very much careful while working on HPLC. Generally in HPLC, particles of size 5 microns or less are generally used, and these particles are not retained by the tubes, so there is slight risk and may cause damage to lungs also. And as the pumps is introduced and it uses high pressure to inject the mobile phase in HPLC, so there is risk while injecting, so pumps should be carefully taken care of because liquid may cause serious physical damage to the body. Apart from this, high voltage is there, and user should take care from this electricity shocks and other things. So as a whole, if I would like to conclude this lecture of applications of HPLC in civil engineering, the application of HPLC is very vast, very wide in sewage quality, in water quality, in chemical admixtures, superplasticizers and cement pest. There is a lot of scope for detection of the key compounds, molecules, and the quantification of the molecules to study the impact of this on the quality of any type of mortar or concrete. So, thank you very much. Thank you.
So, thank you, Dhapekar sir, for your insight on this particular topic.
Thank you, sir.